Hello, my fellow mathematician. Welcome to the study of ordinary differential equation. We are looking at homogeneous differential equation of the first order, and we are looking at the methods by which we can solve differential equation. Now, the equation we are given here, it is an equation which is reducible to first order differential equation. But when it is this way, this equation, it is nonlinear when y is part of q. Now, regardless of the power of n in this y, this equation is nonlinear. So to divide equation 1 by y power n throughout to get y power negative n dy over dx plus y power 1 minus n p, which is equal to q. So we call this equation 3. When you divide equation 1 by y power n, we are going to obtain this. This is dependent by y power n, but you can take the y power n up to make the index negative. Here you have y power n negative 1, and this is y power 1. So that is why here I have written y power 1 minus np. So in this equation, we are going to make the following substitution. We are going to let our z be equal to y power 1 minus n, meaning that our dz with respect to dx will be equal to, we differentiate this part, 1 minus n y power negative 1, because when we are differentiating, we reduce the index by 1. So dy over dx. Then we can divide it by 1 minus n throughout to have the following. So you have 1 over 1 minus n dz over dx is equal to y power negative n dy over dx. So we can call this equation 4. You compare. So compare. We are going to compare equation 3 and 4. You can also call this Roman 1 and also Roman 1. So when you compare equation 3, 4 and Roman 1, we are going to obtain the following. So from 4 we have 1 over 1 minus n dz over dx. So here, where you have y power 1 minus n, we are going to substitute it with z. So plus z p, which is equal to q. That is what we are going to obtain after comparing. We can multiply both sides by 1 minus n to have dz over dx plus 1 minus n zp is equal to q bracket 1 minus n. We call this equation 5. So now equation 5 is a linear equation of first order, and the integration factor will be given by, so integration factor of equation 5 will be given by integral exponential power integral of 1 minus n multiplied by p dx. We call this equation 6. So equation 6 is the integration factor, and it is the one which is multiplied in equation 1 to solve 8 following the procedure which we are going to do. So the next thing which we are going to do, I'm going to show you an example which you can solve using this general formula we have derived here for us. Thanks so much. Remember to subscribe to this channel. Remember also to click on the notification bell so that you don't miss a single video which I upload for us every day. You can also share with the other mathematicians and the scientists so that we may learn together. Thanks so much for taking your time to study with me.